So let's have a look through some questions from the 2025 NHT physics exam. We'll go only through the questions which was done in your class, were done not well. Okay. So multiple choice, we'll start from question 9. Question 9. Multiple choice, we'll start from question 9. Question 9. So we have when maximum flux occurs and maximum induced voltage. So obviously, if we have two magnets, the maximum flux will be when the coil will be perpendicular to the magnetic field. Then will be maximum flux. Because we'll have the maximum number of the lines of magnetic field going through the coil, or angle between magnetic field and normal to the coil will be 0 and or 180 degrees, so cos will be at maximum. Minimum is when it's horizontal. Now, EMF is derivative of the flux, and when we rotate this coil, we will have that. When we have a coil which we will rotate in magnetic field, we'll rotate it, the flux will be changing, depends on the starting position. If it starts from the vertical position, so flux will be cos graph against time. And EMF is the negative derivative. Derivative of the cos is sine. But derivative of cos is negative sine, negative will be positive sine. So EMF will be sine graph. When we have flux maximum, EMF will be 0, because rate of change of flux is 0 at those points. So correct answer is D. Maximum flux when coil is perpendicular to the magnetic field, and maximum voltage when it's parallel, because when flux will be 0, the rate of change of the flux will be maximum. Make sense? Mm-hmm. That question 9. Another question that was not done well is question 13. This one was done particularly bad. And that is so like base knowledge, what the inverter does. Inverter what voltage or current produce solar panels? DC, constant DC. And what we need to supply to our appliances? AC. That's what inverter does, convert DC into the AC. So answer is A. Next question was very better done. Question 14. Question 14. I need to make some picture, otherwise it will not be very clear what's happening there. So question 14. We have two loudspeakers.
Just like you did.
I didn't see. This was next to see. I did this.
That's what I'm saying. These close.
And we have the line.
No, it's not. It's the opposite.
A is the wireless and
QS, line QS that is on any point on this line QS. We have any point of the line QS is equidistant from the loudspeaker. The path different from the sound to any point because it's a perpendicular bisector to the line connecting loudspeakers. So path difference is 0. So it always will be maximum. But when you're walking from X towards loudspeaker to Q, obviously as closer to loudspeakers, the more loud will be sound. So answer is C. Sound level gradually increases.
So what did you add?
I did that.
Yes.
That's right.
Next question that we will look into
Yeah, it's pretty basic voltage.
Question 20. Question 20.
Even explain it.
Well, that was
That's question
So that might be the hardest one to take, especially the worst.
Question 20. We have relationship.
Choose the easiest one.
We have formula for the radius, which is on the formula MV over QB. Or if you rearrange it because we R against V. Those are all constant mass magnetic field. What kind of relationship it is? Straight line. So correct answer is A.
Not parallel.
The bigger is speed, the bigger is radius. So easy question. Was done so bad.
It's the hardest question.
Now, next question that we will look into is question 1b, which is absolutely shocking.
Force was that big.
Wait, people got that wrong.
Question 1b.
It's like the first thing I learned in physics. Never used that.
It's always weird when you do it.
We have
1B by A.
Yeah, on the
two objects A and B. We have 64 newtons acting this way. Mass of A is 12 kilograms. Mass of B you found in part A, that is 4 kilograms. Question is force exerted on B by A. So F A on B. Which force is acting on B? Only force F A on B. There's no other forces because it says on frictionless.
Oh,
So that will be equal mass times acceleration. This is only one force acting, so it's a net force equal mass times acceleration equal 4 times 4 equal 6.
Why 4 not 12?
That's just
Because A on B.
I did that.
Oh, right.
A on B. B has mass of 4 kilograms. B, so mass times acceleration equals net force, second Newton's law. It was shocking that this was not answered well. Now, next question, which was done not well, was question 2. Again, Again, question 2 is so basic question. Explain using physics principle why the airbags reduce severity of the injuries for people in the car. It's based on the second Newton's law expressed through the momentum that Ft impulse equal change in the momentum. Change in the momentum is a fixed thing during the collision. Final is 0. Initial determine how fast you were moving before collision. This is fixed. So airbags increase time of the collision. If time increased, force decreases.
I read that word for word. And I'm
same. How did I only get one mark?
All questions afterwards, individual questions
You have to mention impulse.
afterwards.
That's
Huh?
what it says
You
that.
have to mention impulse.
Yeah, obviously. But
You must say that change in momentum is fixed. You must say that.
Our momentum isn't changed. Yes.
Not momentum. Change. Momentum change.
Yeah.
You are moving 100 kilometers and then you stopped in the wreckage of your car.
At least it's not.
Okay, next question that we will look through will be question for B and C. Question 4B. Labeling forces. And I told you that labeling forces is important. Plus, according to the latest requirements of for marking, every incorrect marked force is minus 1 watt.
Oh, you get negative.
So if you, no, you cannot go negative, but if you get 2 correct, if you get 1 correct, you get 0 marks. If you get 2 correct, you get 1 mark.
So it's almost better not to put an answer.
No.
So you cannot get negative anyway. So, part B, labeling forces. Now, here is a thing which I am not sure about that, how VCAA will require to label it. So, because what we have a car that's from front view, so it's like something like, I know, not like this, but it's a front view of the car, so I will just make it.
It's the bumper.
Yeah. This should not be circled because it's moving this way. And this is the center of the circle. So one force, mg. And the proper way to label it from the center of mass. But I'm absolutely sure that if you just draw from the bottom, it will be accepted. Now we have which force make car actually turning?
Friction.
Friction. So you must show from the wheel friction force because it acts on the tire.
What about both sides?
And there is a normal reaction, and I will suggest that you put normal reaction. I was not taking if you put 1n, I was accepting that, but you better put 2 normal reaction forces at each wheel.
And 2 friction forces as well.
2 friction, but it's hard to label the friction force here as well. That will be the perfect thing. But I believe that if you do just 1 normal reaction, 1 mg, it still will be fine.
N or is N enough? Is F, do we need F N or N is enough?
Both fine. Both fine. You can write N normal reaction or Fn. And part C. Question asked, direction of the force that tire exerts on the rod. Let's have a look on the force that rod exerts on the tire. Rod exerts on the tire, normal, and friction. So what is the net force that the tire exerts on the rod? What is the normal? What the net force? If we have 2 friction and normal, so that will be equal. That will be the net force. Rod on tire. 3rd Newton's law tells us
Equal and opposite
that
reaction.
it has to be tire on rod has to be opposite. So the answer is G. Correct answer is G. That's how you approach
I
it.
have the right idea. I like it.
Now, next question that was not done well. Question 5. 5A was finding that either people get full mark or 0 marks.
Ooh, I'm sorry, the language was wrong.
And
Please
that
from the
is
side, the language was wrong.
question 5A. We do using ratios. We do using ratios. Question 5A. Question 5A, using ratios. We have R cube for Vesta over period squared for Vesta has to be equal Earth cube by period Earth squared. By the way, original Kepler's law was looking like this. What actually Kepler discovered that the ratio radius cube of the radius of every planet of the solar system divided by the square of the period is constant for all planets. He didn't know law of the gravity was not discovered yet by Newton. So what we are using in our calculations of Kepler's law, it's not the original Kepler. This is the original Kepler's law.
But if the ratios are always equal, doesn't mean that the ratios are always constant.
No, this is always r cubed to t squared. It is equal for all planets of the solar system.
Yeah,
always.
but if r cubed.
Now what I'm saying, that this equal gm over 4 pi squared was not discovered yet. G did not, this was not, number did not exist yet. Not like it existed, the nature was not discovered. And from here, we have only one unknown. The period of Vesta, which will be from here, period of Vesta will be equal square root of Vesta over our Earth cube times period of Earth. Substituting numbers will give you 1,318 days. That's how you do it. You use ratio, not other way. B. How B was done? 5 B.
Some students forgot to do tan central 3 for columns.
V equals just square. There's something that you must have on your cheat sheet. V equal root gm on r.
Okay.
Substitute numbers and calculate.
Could you do?
Now, question 6, B, I, double I, triple I. Question 6. Now, what question asks? Direction of the electric field. Question does not ask direction of the force. What some people, it's ask direction of the electric field. So if we have,
How do you know which direction is going?
so we have that magnetic field into the page. Magnetic field into the page. We have negative charge electron, negative charge moving to the right. If negative charge moving to the right, we can see the current in the opposite direction. So magnetic field into the page, 4 fingers into the page, current to the left, force on the electron will be magnetic force is down. Therefore, to move in the straight line, you must have electric force acting up. If electric force on negative charge acting up, so we have plates here, what potential is there, positive or negative? It's positive
So
here.
it's the direction of the electric field from negative to positive.
Direction of electric field from positive to negative.
I forgot.
Then it's the forces, then the electric field is going down.
Electric field is going
That's what
down.
I said.
I wrote that and I still
Wait,
lost it.
Wait, is direction of electric field?
You write it.
Okay,
You write it
I
forcefully.
even drew it for you.
Wait, so this
Yes, you write force.
But I was still correct, I was right wrong.
Mr. V, is electric field from positive to negative, negative to positive?
Direction of electric field is the direction of the force acting on the positive charge. So it will be from positive to negative, yes.
I lost the mark and I don't think it's justified.
So well,
No. I'm really surprised that 6B double I. No, it was done pretty well, sorry.
It was the hardest question I've ever seen in my life.
Triple I. Explain what would happen to the path of the electrons if they were traveling at slightly slower speed. But we have that speed does not affect electric force, because electric force equal charge times electric field. There's no speed there. But magnetic force from magnetic field equal QVB. If it's moving slower, means magnetic force which acting down is smaller. So net force will be up and path will curve up. Okay.
Anyone get full marks on parent play this one?
Question 7. Nobody got all 3 marks. Because, so guys, when you're answering questions, you must answer what question asks you. So, you have to evaluate each of the students' statements indicating where they accurately describe the astronaut situation when in orbit. So, Chen stated the astronaut doesn't experience a force due to the gravity in the ISS because there is no gravity where there is no air and see space in the vacuum, no gravitational force can be experienced. So you need to write that Chen is incorrect in everything. First, gravity acts in the vacuum. Gravity doesn't require medium. And it acts in the space. So he is wrong. Darika, who states that the force due to the gravity is acting on the astronaut in the ISS, but her movement along with the spacecraft in a stable circular orbit creates a force that cancels out the gravitational force. She's partially correct, saying that there is gravitational force acting on astronauts. But that's the only thing that she says right. Because she's incorrectly saying that movement in a circular orbit creates the force. Movement in a circular orbit does not create the force.
Ooh.
It's a result of the force acting at the right angle to the velocity it's moving in the circular motion, constant force at the right angle to velocity. Now, part B describe the astronaut's actual situation, including all forces acting on the astronaut. There is only one force acting on the astronaut, gravity, which is acting as a centripetal force, making astronaut go in a circular path. Astronaut experience apparent weightlessness or zero gravity experience as she is in a free fall together with the International Space Station. So her acceleration is equal to g, as well as acceleration of International Space Station, and normal reaction equal to 0. That must be.
Okay.
Now, next, question 7a. It is shocking. No, sorry. This was done right. Sorry, question 8a was good. Question 8bi. Okay, when many appliances are turned on, the voltage changes. Explain why this occurs. If we turn on more appliances, what will happen? Will be more current will be drawn. As more current drawn, there will be more voltage drop across cables. Question to ask about the voltage specifically.
Wait, but you don't know if they're connected in series or parallel.
Huh?
You don't know if the appliances are connected in series or parallel.
They're in parallel. If there is
How appliance is connected at your house?
I don't know, I'll check.
If they will be in series, what will happen? You turn off one appliance, nothing working. Plus, they will you turn another appliance, and the whole voltage will be redistributed between them as a voltage divider.
Oh, okay.
They're all in parallel, they require the same voltage.
Wait, Mr. Vick, why?
So, more current, more voltage drop across the line.
Yeah.
So less voltage at the house.
Well, why do you circle I squared R? Why do you circle the square?
Because voltage equal current times resistance, Ohm's law. You mixed up with the power.
Oh shit.
Oh, Joseph, it's a classic mistake.
Oh, you did the same thing.
You mixed up voltage with the power.
Mr. B happens to all the best students.
Now, that was question 8. Question 9
No.
up to D was done. No, actually D was done not today. Huh? BII? BII, on one occasion voltage received the house is 210 volts. Current is. So we have voltage in the cable. Voltage in the cable.
I can't, we've got one now.
Voltage drop across the cable equals voltage supplied, which is 220. Voltage supplied minus voltage at the house. Because we have voltage supplied from the generator, lights, and we have a house. So voltage supplied is shared between them, so will be equal to 220 volts supplied minus 210 at the house equal 10 volts. So voltage drop across the cable is 10 volts, and then Ohm's law V equals IR. We have 10 volts, current is 2.1 times R equal 4.8 ohms.
Sure, you get it wrong, you did the same answer for both brands, and you thought there was nothing.
Now,
At least give it a good attempt.
question 10 was alright.
Wait, what about 9C?
What about nines?
9C.
Not 9C.
9D.
Wow, I got a mark off. I don't know why.
Because you did that 4 periods, so you only do half.
Oh, you have to do double voltage.
Well, you did it completely wrong.
No, first, 9C, if we have double the frequency, period becomes twice smaller, but because the same change of the flux happens over smaller time, the amplitude will be twice bigger.
That's a classic question.
Now, D, question D, people did not read the question. If generator can be said to give a constant DC of 12 volts, draw the trace. Constant DC 12 volts. It's a horizontal line, 12 volts. Constant DC.
Yeah, you just did it at 2 blocks.
You get it.
We're also looking at half. See, that's the hardest question in the world.
Yeah.
Mr. That was not allowed to be.
Now, question 10. I am actually not happy with the question 10.
I agree.
Especially part B. And then part A. So, how the flux will be changing? If you move in coil in the magnetic field with a constant speed, so the flux increasing at a steady rate, then when it's completely inside it's constant, and then decreasing at steady rate. How you got any curved things here, I have no idea.
If it's completely inside, then why is the flux like staying constant, not going to 0?
Flux, what is
Flux, not here.
And then EMF is derivative of the flux, negative derivative of the flux, but we can never pay attention to like how they do, so it has to be one pulse here, then 0, and another pulse here.
If it was it'd be perfect.
Thank you.
We did so many such questions.
Mr. B.
Yes.
Why would you say that?
If the loop will be circular, then the rate of change will be changing, yes.
Like this in like a curve instead of.
It will not be straight line, because we will have
Oh, I thought you were talking about this.
Yeah, it will be flux will be changing. It will be flux then will be increasing like this. And then decreasing like this. Think about if you have a circle, you start moving it in, so it will be like this, and then like that when getting out.
No.
Question.
No, both of them will be circular.
If it was a circle, you just need to invert everything.
Which one?
Changing
10D?
the derivatives will be changing.
It was done pretty well.
James, I see a cross on your back.
What question was done very badly is question 13. Question 13.
Right, what about 11C?
11C was done not bad.
Okay, I guess I'm spacing.
Okay, we can talk individually. I'm talking when many people did. Question 13. Question 13. What causes the timing signals of the GPS to require correction? No calculations are required. First, we need to state that GPS satellites are in motion relative to receiver on Earth. Now, someone put them very fast moving, they're not very fast moving. Their speed compared to speed of light is very, very, very small, still very small, but still there is a speed moving. Now, who measure proper time?
Einstein.
What's them?
Satellite or person on Earth?
Satellite.
Or is it satellite will have a proper time? So, their clock moving slower than the clock on Earth, so signal need to be adjusted to account for this
That's what I wrote verbatim and I lost a mark.
Okay, so GPS satellites are in motion relative to receiver on Earth, so their times run slower. Time on the receiver clock is dilated, so runs faster. As clock on satellite and receiver record time differently, timing signals need to be adjusted for this.
Yeah, that's what I wrote. That's the last one.
Okay, we'll have a look later on. Now we have few minutes left, so I'm looking for what else was done. Question 17B.
Do we have question 14?
Huh?
Question 14.
Question 14.
1 out of 4.
Question 14. Oh my God, this with how so many, you have samples how to answer this question. So observation number 1. Kinetic, so we look in which observation can be explained by the particle but not wave. Observation 1. Kinetic energy of the electrons emitted through photoelectric effect depends on the type of metal surface. Yes, everyone agree. Wave theory, particle theory, everyone agrees. So 1, fine. 2, for a particular frequency, number of electrons emitted depends on the intensity. Yes.
Yes.
The wave theory has saying energy depends on intensity. So more intensity, more electrons emitted. And particle theory, yes, say high intensity means more photons coming up, so will be more electrons. But observation 3, the kinetic energy of the electrons emitted from metal depends only on frequency of the incident light. And now, that was a good example when some student wrote everything correctly, but lost all marks. Because they did what called data dumping from the cheat sheet. Not answering what question asked. So first you need to decide that observation number 3 is incorrect. Now you need to explain why wave theory can explain. According to wave model, kinetic energy of electrons depends on the intensity of the incident light, but not on frequency. which is not observed. So that we get the second mark. We say what wave theory thinks, and this is not observed in the experiment. First mark, observation number 3. The second, third mark, we need to explain how particle model. According to particle model, one electron absorbs one photon. And energy of photon is HF. So kinetic energy, question asked about kinetic energy. You must relate it to kinetic energy equal HF minus work function. So if frequency increases, kinetic energy is increases. Intensity is related to number of photons, but not their energy.